Okay, 3.4 in the last lesson we did in class dealt with linear programming. And we said linear programming is the way to find out the optimization process. What's the maximum that we can get in something? What's the minimum? This is something you would use in real life situations, believe it or not. And to do that, they will always give you an objective function that starts with C equals something, and then they will give you constraints. You graph the inequalities, you get all of the dots possible out, and then you come up with what is the minimum, depending on what they want. They want the minimum, they want the maximum, they want both. We are on page 164 and we're doing example 1. And in this case, they want both the minimum, actually, yes, they want both the minimum and the maximum value of this objective function. So, step 1, we're going to graph all of these. Here's the great news. X greater than or equal to 0, I would have to shade all of this. Y greater than or equal to 0 would have to shade all. I'm not going to. The only thing I have to graph is my third one, right? This means y equals 8 when x equals 0, and x equals 8 when y equals 0. This is the standard equation, right? I make my x 0, my y becomes 8. I make my y 0, my x becomes 8. 1, 2, 3, 4, 5, 6, 7, 8. This is the point 0, 8. They're very important that you have to write them down. And then 1, 2, 3, 4, 5, 6, 7, 8. This is the point 8, 0. Okay, I get to draw the line. I have to see where I shade. This is less than. Technically, we know it's under the line. We want to confirm. We're going to pick the point 0, 0, which is right here, and see if it's involved or not. Well, 0 plus 0, 0, which is less than 8. This is my shaded area. Now, when we do this, you're going to notice that we have 3 exactly points that I can get from this function. The first one is 0 and 8. The second one is 0, 0. And the third one is 8 and 0. And now I need to see which one of these represent the maximum, which one of them represent the minimum. Which means for each one of them, I'm going to plug the x and the y into my function and see what I get. In this case becomes 3 times 0 plus 4 times 8. I get a 32 because this is 0, right? This one becomes 3 times 0 plus 4 times 0. It's a 0. And in this one becomes 3 times 8 plus 4 times 0 is 24 because this is 0. I'm looking for the maximum. Here it is. The maximum is 0, 8. This is the max. I'm looking for a minimum. 0, 0 will represent my minimum. So this is where we are. To find the minimum or the maximum or both of them, you first graph your inequalities. Then you find all of the well-defined points, you plug them in and see what you get. We have a second example that we're going to do. And this one is a little bit harder to graph for me also, but we're going to work it together. And we're going to have more than 3 points in this case, I believe. I might be wrong, but I think, no, we still have 3 points. Okay. First of all, what is my objective function? C equals 5x plus 6y. Remember, we never graphed this one. This is the one where we're plugging the points. Here's my constraints. X greater or equal to 0, y greater or equal to 0. We always like that stuff, right? Because that means we're staying in the happy zone of positive numbers. And then I have 2 inequalities to graph. First of all, x plus y greater or equal to 5. And second of all, 3x plus 4y greater or equal to 18. Well, for this one it's very easy. When x is 0, y is 5. When y is 0, x is 5. I can graph this pretty easy. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I kind of draw it, and I'm shading. Where am I shading? It's greater than, so we kind of assume it's on the top, but we want to check. Let's pick 0, 0, which is underneath the line. 0 plus 0, 0. It is not greater than 5, so I already know. Here's what I'm shading, and I'm using this a little bit scarcely because you'll understand in a second what happens. My solution is on top of the line. Let's graph the second one. When x is 0, my y is tricky. Y becomes 18 divided by 4, or 9 divided by 2, or 4.5. When Y is 0, we like it. X is 6. So here's my 0, 6. This is, no, 6, 0, I'm sorry. 6, 0. This is my 5, 0. And I'm looking for 4.5, which would be right here. This is 4.5. This is 0, 4.5. I'm sure hoping you can see what I'm doing. The dot on top of it is 0, 5. We graph them, right? And now I get to get this dot and unite them to the best of our abilities. I'm going to use a ruler and see if I can do it or not. I'm not sure that I can, but I am sure going to try. And you'll understand in a second why I need to try. Because they meet right here. And again, I don't know for the second line, am I graphing on top or on the bottom? But it's very easy. If I pick 0 again, 0 plus 0 is never going to be greater than 18. So I need to shade on top. I'm going to use the red. I know it's not going to work. But here's why that matters. We only care about the points that coincide. Remember how we graph system of inequalities and we shade whatever is double shaded? If you look here, I only have red here. Here I have red and black. I do not have, right? Let me see, black and red. I don't have any red here. I only have red here. This is only black down here. So really, the only points that contain black and red together are 0, 5. The point where they meet, which in my case would be 2 and 3. And that's where you have 2. And then the other point, which is 6, 0. Those are the 3 points that are very well defined. They all contain both of my shadings. And now, once I get those points out, this is pretty easy. C becomes 5 times 0 plus 6 times 6, which is 36. In this case, it's 5 times 2 plus 6 times 3, which is 18, plus 10, 28. And this has become 5 times 6 plus 6 times 0, which gives me 30. I forgot what this is asking for. Is it max and min? Yes. So my maximum, it's going to be 0, 5 is the biggest value. And my minimum, it's going to be 2 and 3. Right? That's my max. I didn't write it. This is my min. And this is how these work. Okay? Again, we graph them. You're going to have to pay attention to graph them to where you see exactly the points that margin both shaded areas, and then you use those points. The last part of this, it's going to be the word problem, which really is a pain, and I'm going to do my best to graph it in here, but this is not going to be easy. We did it in class. I hope you remember how we did it in class. They have a very good graph in the book for you. Now, the problem is really nice, and they give us the functions that we're looking for. My objecting function is P equals 60A plus 50B. How do I know that? Let's read the problem. It says, Plant A earns $60 per bicycle. Plant B earns $50 per bicycle. They want to talk about maximize profit. So my profit is, I make $60 per bicycle for plant A, and I make $50 per bicycle for plant B. This gives me my objecting function. My profit is my objective function. We talked about this when we read in class. Now let's see what we know about this particular problem. First of all, this is a real life problem. So the one thing that I do know for a fact, I'm going to try to graph this. It's going to be tricky. Is that my A is greater or equal to 0 and my B is greater or equal to 0. I need to define this because I need to tell everybody this is in real life situation. Now, they gave us a table, which we really like the table, right? Here's what we know. 10A plus 1B, or 10A plus B, has to be less than, if you read in here, 40,000 hours, because they only can work 4,000 hours, right? Let's look at the machine time. The machine time is 1A, or just A, plus 3B. They only can work 1,500 hours on this one, right? Then for the third one, you have 5A plus 2B has to be less than or equal to 2,300 hours. That's all they can work. The really nice thing about the table is that it sets it up for you in the right way. You can write your equations or inequalities by adding them both A and B, and then you just need to read your problem to know, are they greater than or equal to or less than or equal to? In this case, it's less than because they can work up to this many hours, and then they tell you the solutions. Graphing this, not easy on this type of graph, but I'm going to do my best, okay? So let's do this one. If A is 0, B is 4,000, which is really hard to graph. If B is 0, A is 400. Okay, so this goes in here. Let's solve the second one. When A is 0, B is 500. When B is 0, A is 1,500. And then for the third one, this is just the standard stuff. I'm just doing standard stuff, right? When A is 0, B is 1,150. When B is 0, A is 460. Okay, these are my values. Let's try and graph each line to the best of our abilities. If I look at my B's have really big values. So I'm going to say this is 1,000, this is my 2,000, this is my 3,000, and this is my 4,000. I think that's as far as my B goes, okay? On my A kind of goes to 1,500, so I'm just going to do this as, I don't even know how to do this one. 1, 2, 3, 4, 5. This is 500. 1, 2, 3, 4, 1,000. 1, 2, 3, 4, 1,500. Hopefully this will work. I think this is all we did in class. Let's go ahead and graph the first line. B is 4,000. A is 400. I'm going to try and draw my lines correctly. Okay, to the best of my abilities. I'm going to use a ruler. I know that I'm going to shade all of them underneath it. And here's how I know. If I make them 0, each one of them kind of corresponds. So this is shaded underneath it, right? Now for my second one, my B is 500. And my A is 1,500. Right here. It's going to be a hard solution to get. This is shaded underneath it. And then for the last one, my B is 1,500. Oh no, 1,001, about right here, when my B is 450, which would make it right about here. If you remember, when we graphed it, really what we got with was this little place right here, right? And again, this is going to be almost impossible to do. The one way to do this would be to use a calculator. I don't remember if we did this in class or not, if we used a calculator or not, but that would be a one way. Let me set it up and then restart the video. Okay, graphing the way we graph inequalities, this is what you should get, right? If you look at them, we have 4 feasible points. There's one here and one down there, and one there and one there, right? So I can get those out by just moving my little dot around and go, okay, where am I? I need to make my x0 and see what is my y maximum. And if you go in, you're going to notice that it is 500. So my first point would be 0, 500. We already knew that. Wherever they get together, it would have been right here. That's the common thing. The next point they give us in the book, and I didn't give you problems like this as homework, is 300, 400. My next one is 380 and 200. And my last one is 0, 400. This is 500, 0. No, this is 0, 500, and this is 400, 0. By just looking at the calculator, right? I'm not going to redo the whole thing. You just plug them in and you see which one is your maximum. And it turns out that if you make 300 bicycles by plant A and 400 bicycles by plant B, you get the maximum profit, the most amount. This is hard to graph. I've not given you homework like this, so you should be okay. This is just how it works. You have it as a video. And I think we are done with this one. So, happy homework.